Hello, MYP Integrated Physical Science students. Today we're going to be talking about acceleration. So we came here to the Rochester train station and I'm going to get on a train. I think that's it now. So if I need to know how fast the train is accelerating, I need to know a starting velocity, an ending velocity, and a time interval. Do you know about how fast we're going right now?
Going about 79 miles per hour.
Okay, and do you know about how fast we'll be going when we get to Syracuse?
It'll be about 25 miles per hour.
Okay, and about how long till we get there?
Syracuse is expected to be there at 10:30.
Alright, thanks a lot.
You're welcome. There you are.
Thanks very much. So now we have everything we need to be able to calculate acceleration.
This train is here in our station upstairs. You must proceed directly to the platform at this time.
Well, that's it. Train's here, it's 10:30, we're right on time. See you later. Okay, so I know that train movie, the math in particular went pretty fast, so I'm just going to try to summarize what you need to know about acceleration. So first of all, what is acceleration? Acceleration is how quickly something changes velocity. So in other words, if you have an object that's moving at 2 meters per second and then it speeds up to 4 meters per second, we want to know, did that speed up happen quickly or did it happen stretched over a long period of time? That's what acceleration is. The second thing is we want to look at an acceleration problem, and I'm going to go through the steps a little bit slower than I did in the other train part of the video. Okay, in this problem it says that a passenger train is at rest at a railway station, and after 9 seconds the train's velocity is 27 meters per second traveling east. Calculate the train's acceleration. So what we're going to do is we always start by writing our given information, and we're going to write VI, which means initial velocity, and it says that we're at rest. So at rest is 0 meters per second. And then we also have a ending velocity of 27 meters per second. So we're going to write VF for final velocity. And that is 27 meters per second. And it also gives us a time which is 9.0 seconds. And so what we have to do now is we're going to use our triangle, but it's a different triangle than we did before. We're going to have the change in velocity over acceleration and time. Now that little triangle here, that's a symbol that means delta. And delta means change. So to calculate the change in velocity, we have to subtract the final velocity from the initial velocity. So we're going to have VF minus VI. So this is before we even start using the triangle. We have to find out what that change in velocity is. So we have change in velocity equals 27 meters per second minus 0 meters per second. Okay, so when we put that together, 27 minus 0 is obviously 27. Now, that might seem obvious in this problem, but in a lot of problems, it's not going to be minus 0. It's going to be some other number that you're going to have to subtract. So we're looking for the difference, and we found it. So now over here, we're going to go find out what our equation should be. We're going to cover up the thing we're looking for. So we cover up acceleration, and we have a formula which is now a equals change in velocity divided by time. Okay, so we're going to have a equals, our change in velocity is 27 meters over seconds, and our velocity, our time that we're looking for is 9.0 seconds, and we're going to divide that, so that's going to wind up being on the bottom of the equation. So now we're going to solve with algebra. That's the next step in our process that we always do. So 27 divided by 9.0 is 3.0, and nothing cancels on the top and the bottom, so we're going to have meters. But on the bottom of this fraction, we have to multiply seconds times seconds. So that's going to give us seconds squared. And you're welcome to write your answer in this format, or sometimes people write it like this. But as long as you have one of those two forms, you are correct. So that means that the train is accelerating at 3.0 meters per second squared.